Welcome back, everyone. This is part 2 of our 4-part series on the epidemiology of pandemics and specific lessons for COVID-19. My name is Kyle Fries. I am the epidemiologist for STC Health in Phoenix, Arizona. In this part, we will be talking about some of the history of pandemics over the past couple hundred years with some specific examples. And then in part 3, we're going to dive into COVID-19 specifically. I'd like to start with the most famous outbreak investigation in modern epidemiology, and that relates back to the cholera epidemic of 1854 in London. So in 1854, there was an outbreak of cholera in the Soho neighborhood of London, which this map shows, and it killed 616 people in about 10 days. Now, mind you, this is back in the days where miasma theory predominated the landscape, which basically stated that noxious fumes from decomposing organic matter was what caused certain types of infectious disease. There was a guy who thought a little bit differently. His name was Jon Snow, but I'm sorry, Game of Thrones fans, it is not this Jon Snow, it is this Jon Snow. Jon Snow was a physician in London back in 1854, and he had an idea that these types of infectious diseases were not caused by noxious fumes, but rather contaminated water. So what Jon Snow did is he mapped out the entire neighborhood of Soho in London in 1854, and he went door to door and interviewed people and found out how many deaths from cholera were from each household. And on top of that, he went through and he mapped out all of the different water pumps where people got their water in this neighborhood. So I'm going to show a little blown up version here in a second. So this is right in the center here. So as you can see, he went door to door and found out how many cases of cholera death were in each household. So if you look at that largest bar kind of center left of your screen, each one of those darker bars represents a death from cholera in that single household. What he did is he did a brief outbreak investigation. What we would do now is just calculate an odds ratio comparing those who died, those who didn't, and his theory was where they got their water. He found out that the highest odds of death were associated with people getting water from this particular pump, now famously called the Broad Street pump. Side note, this does still exist, obviously not functional, but you can go and actually take pictures of it. Across the street, there's a pub called the Jon Snow, so that's really fun to do for a nerdy epidemiologist. Basically, going back to the serious stuff, he found out that this pump was associated with a higher risk of death in this neighborhood. So what he did, he implemented one of the first public health interventions. He had that pump shut down, and lo and behold, the outbreak ended nearly immediately. So this is an example of, like I said, one of the earliest examples of an outbreak investigation and what many call to be the beginning of modern epidemiology as we know it. In more recent memory, the Spanish flu of 1918 was the deadliest of all pandemics in modern history, killing at least 50 million people worldwide. Some experts actually put that closer to 100 million. And just in the United States, it killed 675,000 people. Looking back at the data, many experts think that about a third of the world's population was infected at one point or the other. I'm not going to belabor this point too much because there's a lot of information online that you can look at. But again, the Spanish flu of 1918 was kind of the benchmark of how bad a pandemic can actually get. The way that it spread, this is showing the world in the second wave of this pandemic in the fall of 1918. Even with real basic methods of transportation, this was able to work its way around the globe in about 4 months. So through shipping and trade routes, migration routes, you can see that things pretty much started at coasts and then worked their way inward from there. I show this because the second wave of the Spanish flu was by far the deadliest. Another example of a pandemic that you've probably heard of was the 2002 SARS pandemic. I show this for a couple different reasons. First is to show the distribution of cases. So by country, we can see the number of cases in blue or black, and then the number of deaths in the red parentheses. SARS was interesting for a couple of reasons because, one, it acted really, really quickly. So the case fatality was relatively high once you're infected. And then also in a lot of pandemics, we see more of a U distribution in the numbers infected. So it's usually in the younger groups of people or in the very old groups of people. So those that have either immunocompromised systems or are more at risk. This was interesting because it had more of a W distribution where a lot of people that were young and healthy were also impacted. So in terms of raw numbers, SARS did not kill a a huge number of people, but again, between the two things that I mentioned, which is why SARS was such a big deal back in 2002 and 3. Then finally, for this mini lecture, we're going to wrap up with the 2009, H1N1 swine flu pandemic. What is shown here is the epidemic curve of that pandemic, moving across in time from 2008, 2009, and 2010, and then the number of positive cases per day as you move through time. You can see this had kind of three peaks, two main ones of confirmed H1N1. So we can learn a lot of different things from epidemic curves. I'm just going to focus on a couple here. So the first thing here is that we see multiple peaks, which is indicative of a propagating source epidemic. So in like foodborne illness, if everyone eats at a tainted buffet, you would usually just see a single peak, if you can just ignore those two larger peaks for now. However, in this type of infectious disease, once a pathogen is introduced in the community and it starts spreading throughout that community, we said it's population spread or community spread, we start seeing these subsequent peaks after the first one. Another thing to note here is that in this sort of epidemic, each subsequent peak after the first is progressively of higher amplitude and higher amplitude and higher amplitude until the epidemic stops. So in our final part here, I'll just briefly mention, I will dig into it a little bit more in parts 3 and 4. This is where the term flattening the curve comes in, because if we can get these huge spikes mitigated, we can remove some of the stress placed on healthcare systems. So that's a little teaser for future parts, but overall, that was a real brief history of some notable pandemics. Again, if you have any questions or want to have some additional resources, please do not hesitate to contact me. Thank you so much for listening. Talk to you soon.